This is my final version of a bullet loader for a star press. There wasn't a lot of information out there for making a press that would, flip the bullets over for you. I had to figure that all out by myself. There was a few ideas out there, but not very much. So we'll start at the bottom here. As you look at the plate right here, this lever right here is the automatic bullet feeder. That is hooked up to an electromagnet with the arms, and as the electromagnet feeds in, it presses on the feeder tube. That in turn is hooked up to a switch under the lever arm. Once that engages, then the electromagnet shoots over and drops the bullet into the sizing die. The other problem is, in the manual for the Star, they also talk about that maybe every 15 or 20 rounds you'll feel resistance on the handle, so you should drop a waxed lube bullet in, and then that lubes the die again and makes everything freed up. So I made a secondary system right here that drops in a lube bullet. That I just feed on top of the tube here, and I'll just load up that with the lubed sized bullets, push them in when the handle gets a little hard, lubes it up, and it'll run clean it again. So we'll take a look at the top and continue from there. Alright, we're at the top of the machine now, looking down into the hopper, and this is where all the magic happens. Over here you can see I installed a flapper that does two functions. One, this particular motor that I have in here, it's a Rotisserie Motor, will start up in either direction. I wasn't aware of this when I bought it, but it still works. That in turn keeps the feed plate from starting backwards. Once it's given a little resistance, it'll go into a forward motion like that. Also, that kicks off any bullets that may be sideways in the holes to drop in the hole. So as they come up, you can see there's the hole right there that the bullet will drop down. If they're nose down, they'll drop straight through that tube. If they are nose up, you can see the small lip right there. That won't allow the bullet to drop through. It continues over. There's a small trough cut in to the bottom plate there, and then there's an angle right over there, and you can see the angle. The base of the bullet hits that and starts doing a flip over motion. So I'll take the plate off just to show you the grooves I cut, and we'll go on from there. Okay, bullet plate removed now. You can see I also installed small ball bearings all the way around the bottom plate. I found in my earlier tests, once I loaded up a good amount of lead in there, there was too much resistance between the two plates. So I put the ball bearings in there to make it ride around the whole area easier. Now you can see after the drop tube how I cut that trough in there. That's where the base would ride, hit that, then there's a small block right there that helps continue the rollover process. Over here I also cut another groove, and that would allow the tip of the bullet to ride around as it comes around to the drop tube to locate the bullet easier. And once that's done, then they just keep on going down. Okay, we're at the bottom again. Just a few more things to point out that's going on in this system is you have the feed tube from the hopper that goes down to the press. I needed a way to control how many bullets would fill into that tube without overfilling. Inside these little collars right here are infrared sensors they are hooked up into a box over here that I built a circuit board for, and that controls how the bullets come through. There's two of them. There's one at the bottom and there's one at the top. It allows the bullets to fill to the top, come down to the bottom, and when it goes below the bottom, the tube will fill up to the top again, which will prevent short cycling in the motor. So that's a cool thing. I believe the guy's name was Bearing One. I'll try to put the link in there. He showed you how to build this circuit board. So that is that. Down at the base, I have the aluminum plates, and I have my high-tech old GE iron on there for heating the wax. Not too high-tech. The high-tech part of it comes over here, and that's my PID unit, which also is hooked to the iron. There is a probe right here that goes into the plate, and that'll hold that at my desired temperature for the wax. This wax seems to work really good, about 130 degrees, so that's how that works. So that, and I got the air pressure on there. There's a lot of information out there. I don't have to cover that. So after this, we're going to load up some. I'll let you watch how the machine works, and then we'll do it from the top, and then we'll go down to the bottom. Okay, we're ready to fire this thing up. I got a coffee can of bullets sitting here. These are 200 grain semi-wad cutter 45s. That's what I've been running. I dump about a half a can in. The can holds roughly 350 rounds. I just don't want to put too much weight onto the motor and overwork it. So we're almost ready here. Now I just got to reach under, turn on the plate. Okay, you can see it tried to start in reverse, but there it goes. Okay, I'll show you how this feed tube system works here. So I'll turn on the unit and let the bullets drop down. As you can see, it hits the top center, the motor shuts off, and we're ready to go. Now when I start loading, it won't start up until it gets to that bottom center. Okay, we've got the air hooked up. I'm running 15 pounds, 131 degrees on the wax temperature. The hopper's ready, and here we go. Okay, now I can start to feel more resistance on the handle. So I'll just push in by hand. This is one that's already lubed. Drop that in, run that down. That lubes the die again. So that's it. Okay, I'm back to the hopper again. I just wanted to show you one other thing. I got a handful 230 round nose 45. That's all I got. Most of what I run are the semi-wide cutters, but they feed through this thing fine too. So just to show you that. Okay, I just wanted to show everybody this system. Anybody that's interested, it is a doable project. It didn't cost me a lot. I had the steel laying around for the framework. The motor from Lowe's was like 30 bucks. The electronics for these sensors, that was a little more pricey. I think that pulled in around 70 bucks. And everything else I had. So, you know, that's the whole equation on my end. I had some things, so it didn't cost that much. So I got 100 bucks invested in this. So for anybody interested, it's a doable thing. It takes a lot of patience. Ran well over 2,000 bullets through this. Only had one that flipped over the wrong way. Had to pull that out of the tube. But still, that's a pretty good success rate. The commercial units, I've seen for well over $1,000, and people were complaining they weren't reliable. So anybody interested, it is a doable thing. Take your time, keep your patience, and good luck.